This video is part of a plan reading series, specifically framing and how to read your framing detail. We're going to break down all the different lines and symbols that you see on a framing detail so that we can look at it like an inspector would look at it, and also help you avoid any costly mistakes or red tags on the inspection. We're going to look at what does a framing detail tell you, and we're also going to look at PSLs, LVLs, different point loads, and we're going to discuss why certain framing details get flagged on an inspection and why those are so important in your actual framing. As an inspector, as I talked about in the foundation video of the series, building from the ground up is so important so that you're supporting everything. Now, when I go and do an inspection, once it's under roof and they're calling for their framing, mechanical, and electrical inspection, this is where we start at the top of the structure. We're going to start at the roof line and follow all the load paths down. We're going to look at how the roof is framed and how the rafters are supported by the walls. Okay, so continuing in our plan reading series, if we go to our architectural drawing sheet index and we look over at the roof plan details, we see that A 2.1 is our first and second floor construction plans. If we need to go to wall sections, we can go at A 4.0. But the sheets that we're going to be covering today, or that we're going to be looking at for our framing detail, is the A 2.1 and the A 2.2, which is our first and second floor construction plans, including the basement. And then we're also going to be looking at the roof plan details. So if we look at the roof detail I have up now, we start from the bottom and work our way up. We'll go over some of the details that we see here. So we see that it's 2x10 rafters, and we have two hips in the front elevation of this home. So we have a 2x12 valley rafter for these two hips. It tells us it's an 812 pitch overall on the roof, and that's a pretty steep pitch at 812, so it rises 8 inches vertically for every 12 inches horizontally. Continuing, you see that we have 2x12 rafters, and they're spaced 16 inches on center. We have a ridge board, not a ridge beam, so we have a ridge board for support of the rafters. You can see the architect gives the span of the rafters, and he tells us that it's 17 by 11, 17 feet 11 inches. He gives a max span. Then he also mentions the table that you can refer to in the IRC, the International Residential Code, for span of rafters. So as an inspector, we're going to look at any posting for that ridge board. We're also going to look that the rafter cuts are tight to the ridge board, that that angle cut is tight and that there's no gaps in there. We're going to look at how that load is being carried. How is that load, that roof load, being carried by the outside walls? Okay, next we go to the sheet for second floor framing. And if we look at this detail, I'll make it a little bit larger, but it tells us we have a cathedral ceiling in the master bedroom, that there's no flat ceiling. They talk about dummy rafters, which we'll talk about a little bit more as I widen the plan detail out a little bit. And if there is a dummy rafter, we want to make sure that we have a ridge beam or we have something that's supporting the roof structure. You want to make sure something is tying those rafters together. Also, we'll look at the window details. They're showing a 2.0 by 2.0 and a 4.0 by 4.0, and we'll explain that a little bit more once we widen the detail out. So on the plan detail, you see the term dummy rafter. And what that is it's going to be a rafter that's going to follow the actual true rafter that's supporting the roof, and to create some type of a vaulted ceiling effect. So it's going to have no structural value, but it may help with insulation. It may help with drywall, having something to attach a drywall to. Then as far as the windows go on this detail, it shows us a 2.020 fixed, a couple places, and then we have 4.040 gliders in a couple places. So the fixed, as it states, is approximately a 2 foot by 2 foot window, like the one I have up here, that's going to be fixed. You cannot open it. The glider would be a sliding window, and each gliding panel is 2 foot by 2 foot, and it's a glider with an overall opening of 4 feet by 4 feet roughly. Okay, now when we move on to the first floor, we're going to be looking at PSLs. So we have some callouts for a 3.5 by 5.25 PSL. We also have supporting LVLs. And as an inspector, when we see things like this on the plan detail, we know these are important because these are point loads. They're carrying some type of a load. When the architect is designing the building and adding a structural member like this, he's doing it for a reason, because there's some type of a point load present. Also, we're going to make sure if there's any hardware that he calls out, that hardware is being followed. So again, when you're looking at this plan detail, just in an overall view, you always want to look for point loads. You want to look for lumber that seems like it's beefed up in certain areas. If you see PSLs or LVLs, you want to bring your attention to those points, because those are usually areas where there's some type of a point load or some type of a concentrated load being carried. So if I widen out the view here on this first floor plan detail, you see that we're concentrating on the den and study. So as we look at the detail, we'll call out certain things here, but then I'll also discuss that connection that the architect calls out. So going from the bottom up again, we see in that area over the entryway, we have a triple 2x10. So we have 3 2x10s that are acting as a beam. Again, that's something that should bring your attention to it to realize that there's a load being carried there. And you want to make sure that the carpenter actually has 2x10s and actually has 3 of them. I've often gone on inspections where the contractor eliminates an LVL and just uses conventional lumber, or where they're calling out a triple or a double 2x10, 2x12, and the contractor eliminates one of them. And often I'll hear that the architect is overbuilding it. And what we do in the field is we say, hey, we're fine with that as long as you give us a letter that's stamped and signed with the architect's seal that he's okaying what you're doing here, this change that you're making. And oftentimes we find that we go back and the lumber was added or the LVL was added because the architect says, no, I'm not going to give you that letter. I want it built the way that I designed it. So if we continue up on this plan, you see that we have the 3.5 by 5.25 PSLs called out. And there's 3 locations where they're called out. Now, again, when you see something like this, you know that from the upper level, from the second floor, and also at the roof line, starting at the roof level, that there's some type of a load that's being carried down. So you always want to look at these load points and make sure, starting at the top of the structure, that that load is being carried down ultimately to the foundation footing level, that you have a solid load-bearing point that's being carried all the way down to the foundation and footing. Okay, then you can see that they're calling for a double LVL. So we have an 1.75 by 11 7/8 LVL that's carrying a load over an opening. So you have a wide opening. You have a 6 by 6 by opening going into the den study. And in that entranceway, you have this LVL. Because of that opening, and you took that section of wall out, so to speak, you don't have a top plate, you don't have studding, and you don't have a bottom plate carrying that load any longer. So with that wide opening, that 12-foot wide opening entrance into the den, the architect has done the calculations and decided that an LVL is important to be installed in that location. And then if you look at the joist, the floor joist above will be 2x10 joists, and those are going to be 16 on center. Now back to that connection that the architect talked about. He wants a top mount connection over the LVL header. He's talking about a connection point that's going to be secure to the top of the header that's going to be holding that triple 2x10. Now just to explain a little bit more about what is an LVL, what's a PSL. So I have this slide up here. This is showing you an LVL beam that's posted by about 6 2x4s. So that's the post carrying the weight of that beam. Whatever load is being placed on that beam is being carried down to the foundation and ultimately the footing of this building or this structure. And then you see you have joists hangered into this LVL. So this LVL is carrying quite a load. You can see that it has 2 floor sections that's being carried by it. And again, the architect decided that this was the size LVL required in order to carry the loads that are being placed on it. And ultimately, the post was the right post the architect determined to carry it to the footing foundation level. So an LVL is an engineered beam. A PSL is going to be something that's found more in posting. So the LVL is glued together for spans. The PSL is strands aligned under pressure, and it's used typically for columns. So you're going to see PSLs used mostly for columns. And in this slide, this would be an example of a PSL post carrying a truss girder, which that path would continue down all the way to the footing and foundation level. Okay, in the garage section, we're going to see triple LVL spanning the garage width. Also, we're going to see the call out for the steel columns. And then also we'll see some fire code requirements here regarding the 1-hour separation wall and the 20-minute door. So if we look at the garage detail now, we see that it's 2x10 joists, 16 on center. Okay, at the bottom, we see that we have the triple 1.75 by 14-inch LVL. We also see the 3.5-inch columns. So these would be the standard pipe columns that we're going to have that go down to the footing. And that LVL will be the beam between those 2 columns. So it'll be supported by the columns and carrying that load down to the foundation footing area. Also, you see that we have the 1-hour fire partition. And I didn't get it in the shot here, but the architect is calling for 5/8 type X drywall on both sides of this wall. So both sides of the stud, he's calling for 5/8 type X. And then the drywall would have to go up to a ceiling that's drywall, or it'd have to go up to the deck. So to sum it up, you always want to follow the load path, starting at the roof, to the walls, to the beams, to the posting, to the footing and foundation finally. Missing one of these steps obviously could be more than just a failed inspection. It could be a problem later on with the structure. So it's important, if you're the contractor, a carpenter or serious DIYer, that you're following the plan detail, or that you're getting it in writing if you change something. If you feel you can change something, you need to go to the architect, the design professional, and ask him, am I able to change this triple 2x10 to a double 2x10, or am I able to eliminate this LVL? Oftentimes you'll find you're not going to be able to do that. You're not going to get the letter and the stamp of approval. The slide I have up now is a great example of everything put together. It's showing that you have an LVL that's posted down with several 2x4s, and then also the kind of load that can be placed on that LVL, and helps you to make sense of why they're using such a big piece of lumber here. This is carrying the header on a second floor. And if you look at this header into the LVL, this is another example of a certain type of a beam. This is called a flitch plate. This is a beefed up beam that's made in the field. And you're going to see there's a certain requirement for the steel, for the bolts, the bolt pattern, the spacing of the bolts. This is a lot of information to cover in a short video. I have a full breakdown in a blog post on my site, buildingcodegeek.com, and I'll leave a link in the description so you can check out the full post. The next video in the series will be reading an electrical detail. I already have a post up for that, and I'll also leave that link in the description. If you want to get the full breakdown, you can go to that post. So I hope this video will help you read your next framing detail. If you liked the video, remember to give me a thumbs up, and remember to subscribe, and thanks for watching.